Okay, now we discuss theorem number 4, that is converse of theorem 3. Okay, so before reading the definition, the statement of theorem 4, we see what is the mathematical meaning of converse. Okay, converse in a conditional statement, if-then statement. Converse changes the if-then, means hypothesis and conclusion. Means in a conditional statement, in a if-then statement, we go from hypothesis to the conclusion, but when we need its converse, we go from conclusion to the hypothesis. So this is the concept of converse. Simply, when we if in a if-then condition, when we change the if and then, okay, if this thing will happen, then that will happen. In such kind of conditional sentences, when we change the conclusion into hypothesis, it's a converse statement. We will more clear it with some examples. If it is a Monday, then it is a weekday. Now, if it is a Monday, then it is a weekday. Okay, then it's a true statement. Its converses, if it is a weekday, then it is a Monday. So whether it is necessary that if it is a weekday, then it must be a Monday, maybe it's a Tuesday. Yes, possible. So converse is not true here. Okay, so converse may be true or converse may not be true. We will go to the other example as well. If two angles are congruent, means if two angles have same measure, then they have the same measurement. If two angles are congruent, they have same measurement. Or its converse is, if two angles have the same measure, then they are congruent. So its a converse is true. Its converse is. Now in theorem 4, we have a transversal intersect two parallel lines. We have a transversal line N intersect two parallel lines L and M. The alternate angles so formed are congruent. The alternate angles that are formed are congruent. This 1 is alternate angle of 3, and this 2 and 4 is another pair of alternate angles. So these two pairs, this first one and this second one, pair of alternate angles are congruent, means having same measurement, that we have to prove. Like now we have to given line L is parallel to line M. This is a sign of parallelity. Okay, so line L is parallel to line M, and line N intersect them at points A and B respectively. Line L is parallel to line M. We will put an arrow to show that these two lines are parallel, and line N intersect them at points A and B. Line N is cutting them at point A and B respectively. To prove that angle 1 have same measurement to angle 3 and angle 2 has same measurement, means is congruent to angle 4. Proof. On contrary basis, we take, suppose angle 1 is not equal, has no equal measurement like angle 3, but angle 1 is congruent to angle ABC. Now the angle ABC from figure is A, this is B, and this is a C line, so the angle ABC is only that part. Okay, so we take on contrary basis, on opposite basis, that angle 1 is not congruent to angle 3, but angle 1 is congruent to angle ABC, where BC does not lie on M, where the line BC is not on the line M. So the concept is, what we have to prove, that one angle is equal to the angle 3, but we are taking on opposite basis that angle is not equal to the angle 3. Instead, we are taking angle 1 is equals to the angle ABC, which is less in measurement than angle 3. So we are taking on opposite basis. So statements, since angle 1 is congruent to angle ABC, by supposition that we have, suppose L is a line parallel to the line BC. The line L is parallel to the line BC. Okay, so angle 1 and ABC are congruent, theorem 3. We have taken that angle 1, as we have supposed that angle 1 is congruent to angle ABC, so these are two alternate angles, and if two alternate angles are equal, the two lines, coplanar lines, are parallel. That is the proof of theorem, statement of theorem 3 that we have proved. So according to theorem 3, line L is parallel to the line BC, but line L is parallel to the line M given, and as we have given that line L is parallel to line M, okay, given. So again L is parallel to two intersecting lines M and BC, which is impossible. Now the statement saying L is parallel to two intersecting lines. These are the two intersecting lines M and BC. This line L is parallel to two intersecting lines, but which is impossible because of the by Playfair's axioms. And in Playfair's axiom we have seen, and in Playfair's axioms we have seen that both of the two intersecting lines cannot be parallel to the same line. Means if these two lines M and M are intersecting, these two cannot be parallel to the line single line L. So this is the statement of Playfair's axiom. So similarly, these two lines M and BC and M cannot be parallel to the single line L. So angle 1 is, so these two statements cannot be true at the same time. So in this context we get the conclusion that angle 1 is congruent to angle 3. Our supposition that angle 1 is congruent to angle ABC leads to an absurd result. Absurd means wrong result, or we say illogical result. This gives an illogical result. So this is not true that angle 1 is equals, it has same measurement of angle ABC, but angle 1 has measurement of angle 3. Similarly, we can prove angle 2 is congruent to angle 4 by the above process. This is a complete proof of theorem number